Okay, we want the Taylor series here for the function 1 over 1 minus x squared. It's actually the same as the function 1 over x minus 1 squared. And I have a funny feeling because the signs, it might be a little bit easier to be working with this. Okay, so let's start getting some derivatives here. Oh yeah, so that note, then f of a is 1 over a minus 1 squared. Okay, so f derivative x, see that's a minus 2, isn't it? So bring down the power and reduce the power by 1, so minus 2 becomes minus 3. And then multiply by the inside derivative, which is 1, so that's nice. So then that means then that f dash a will equal minus 2 over a minus 1 cubed. F double dash x, bring down the power, so that becomes a positive 6. Reduce the power by 1, so that's a 4. We can see what's happening here. F double dash a will equal positive 6 over a minus 1 power 4. So let's try and figure out then what the nth derivative then at a would be. So 1 is a 2, 2 is a 6. These are going to be factorials because that 6 is actually 2 times 3. So it's the factorial of 1 more than where the derivative is. So that's n plus 1 factorial. The sign alternates, so odds are negatives. So that's minus 1 n. It's always going to be a minus 1 here and 2 more onto the number of derivatives. So that'd be n plus 2. Okay, so therefore our function f of x will equal the sum from 0 to infinity. This over n factorial. So note that n plus 1 factorial over n factorial is just n plus 1. So it'll be minus 1 power n times n plus 1 over a minus 1 power n plus 2 times x minus a power n. So that looks like the Taylor series expansion at a for that function here. Obviously, x is not 1 as well, actually. Now, in this question, we're not going to look at convergence. We're just trying to find the Taylor series. I probably only has a convergence radius of like 1. Well, actually, it depends what the A is too, I suppose. And anyways, we are just trying to find this Taylor series here. I think that is all okay here.